In the measurement of physical quantities, we are going to start with the temperature measurement. So in temperature measurement, we are going to study three kind of sensor can be used to measure the temperature. They are thermocouple, RTD, and thermistor. Each of them are having certain theory which used to convert the heat to electrical quantity. The electrical quantity at the output of thermocouple is voltage, RTD is resistance, thermistor is resistance. Let us see what are the theories which we are going to depend on. We will start by thermocouple. Thermocouple is nothing but two material, wire of two material are joined together, material A and material B are joined at certain point. That's it. So before we proceed to get the idea, the type of material, this material and this material, the combination of material will decide on the type of thermocouple. Like for example, we will have the material are coming in the table after a while, but we are going to find the types as E type, J type, T type, K type, R type, S type, and they are not the only types for thermocouple. There are many types, but these are the most famous types of thermocouple. So what is the difference between E and J, J and K, K and T? Of course, the difference will be in the characteristics, which you can see in front of you, and in terms of construction, the material which made them. So the idea which will be used to get to make use of the thermocouple is like this. If we are having two material A and material B, two different material, and we join them at certain point, at the junction, if we apply heat, as you see here, if heat applied at the junction, and we close the wire from the other side, we will find that a current flowing in this loop. There will be a current flowing in this loop, and the current is proportional to the heat applied. So that's the idea. Just two material joined together at certain point. We close the circuit from here. When you apply heat, you are going to get current flowing in it. This is what is called Seebeck effect. Seebeck effect. So Seebeck effect is nothing but when we apply temperature to a junction, it's going to cause current flowing if we close the loop. Now from Seebeck effect, we are going to come out with Seebeck voltage. As you see here, when we have two material, as I mentioned in the previous slide, when we close the loop, we are going to get current flowing. What if I open it? If I open the loop, as you see here, you are going to find that there is voltage VAB, which called Seebeck voltage. It's proportional to the applied heat. So the applied heat here will be converted to voltage VAB. That's it. We call the voltage again, we call it Seebeck voltage. And the Seebeck effect, we will find that the voltage VAB, which I mentioned just now, is proportional to alpha into T. The voltage VAB is equal to alpha into T, where alpha is the Seebeck coefficient and T is the temperature. Okay, so the voltage VAB is equal to the constant or the Seebeck coefficient into the temperature. From there, we can find the relation between T and the voltage, the temperature and the voltage. There is another effect called Plater effect, which opposite to Seebeck effect. Plater effect is saying if you are applying if you are applying voltage, you are going to get heat. It's the opposite. If you are having two conductors and you apply voltage here, you are going to get heat here at this point. Okay, now if I want to make relation between voltage and temperature for a real sensor, the voltage is going to be equal to what you can see here. V is equal to A into T plus half of B into T squared plus 1/3 of C into T cube, and the unit is going to be volt, where A, B, C, D, A, B, C, yes, A, B, and C. I mean, this A, this B, and C, they are depending on the thermocouple material. So, which means the factory which manufacture the thermocouple, when they manufacture it based on the material used to make the thermocouple, they are going to come out with this constant. So, in the data sheet of the thermocouple, you will find these constants. The sensitivity of the thermocouple is finding relation between the change of the voltage to the change of temperature. So how the change of voltage will be met by change of temperature. The rate of change in temperature will cause a rate of change in the volt. So this relation we give it, or we can say it's a sensitivity. So the sensitivity is found mathematically as dV by dt. If you consider the equation given in the previous slide, the derivative of that equation equal to A plus B t plus c t square. So when we differentiate it, we got this value which known as the sensitivity, and its unit is voltage per degree Celsius. Now if I want to look at the characteristics of thermocouple, there are many types of thermocouple. Many companies are producing the thermocouple, so each company will produce the characteristics for the thermocouple. From the characteristics, you can see here I'm giving variety of types, J, K, T, E, S type. Each of them are giving relation between V and T. So let's take, for example, this one. If the temperature is 600 degrees Celsius, that means the voltage you produce at the output will be like 45 millivolt. 45 millivolt. If I take, for example, this type, at 1000 degrees Celsius, you will find that the voltage is 40 millivolt. That's what we mean by the characteristics of the thermocouple. Now, if I want to measure the quantity, measure the voltage, we agreed now that the applied temperature will be converted to voltage. So if I want to apply the measure the voltage measured, here we are applying heat. The heat is converted to voltage, so the voltage between this point and this point. We want to connect it, so we will connect it to the voltmeter. Remember that the voltmeter is having a conductor inside. So the conductor is, let me take different color. I will take this color. So the conductor is having different material. So we are having now junction between material red and the blue, this junction, and junction between the red and the green, and another junction between the blue and the other green, because inside the voltmeter the wire will be copper. So the problem is, when I measure the voltage here, the voltage coming here is coming as a result of 3 different voltages. One of them is the main junction which we want to measure, and this junction which affected by the ambient temperature with this junction which affected by the ambient temperature. So we have to find the solution for this problem, because this is going to give us error in the measurement. The solution is by putting a reference. So what we mean by this, let us assume that we are having copper with constantan. So material is copper and the other material is constant. And we want to measure the voltage at the output. When we keep the constantan, which is the blue one, if I connect it to this side, it's going to cause junction here. So this is the problem which you want to eliminate. How about the other side? For this copper, if I connect it to the terminal of the voltmeter, is connected to copper. So no junction there. If a copper connected to copper, no junction. Junction means voltage generated. So this junction going to cause this voltage. And this junction supposed to make a voltage, but since this is copper and this is copper, no voltage will be generated. In this case, we are going to consider, so far I have only this junction. Okay, besides that, we are going to do something. That thing is making a junction, and we will consider it as a reference. And that junction is going to be in what is called ice bath. How to do it? We are going to make a constantan with copper in a junction, as you see here, and it's going to be this junction. Why I am doing this? because in this side it's copper which connected to copper, so no junction going to be seen. From this side is going to be the constantan. So what about V2? Because once there is a junction, there is V2. V2 is a value, it's certain value, but I will force it to be 0. How to force the voltage here to be 0? We are going to put the junction J2 in ice bath. So if I put it in ice bath, that's going to cause V2 equal to 0 because T will be 0, so the voltage will be 0. Here we can say that V is equal to V1 minus V2. V means the voltage measured. The voltage measured by the voltmeter is this voltage minus this voltage. Now let us look at the source of each voltage. The source of each voltage can be calculated as alpha into the temperature junction. Alpha is the same because it's the same sensor. That's why we write it as alpha into T1 minus T2, means T junction 1 minus T junction 2. If the temperature in junction 2 is 0, that means we are going to have alpha into Tj1 minus 0, which remain as Tj1. That means the only voltage affecting the measured quantity, this voltage, is going to be this temperature. No other temperature will affect the measurement. Here I am showing a table with variety of thermocouples with the material. So here it's, for example, E-type is a chromal with constantan. In terms of sensitivity, it's having a sensitivity of 68 microvolt per degree Celsius. He mean here every change in the degree Celsius by 1 will cause a change in the voltage by 68 microvolt. Okay, that's what he mean by that. We can use it to measure a temperature from minus 200 degrees Celsius up to 900 degrees Celsius. I mean, you can find under this type, E-type, many sensors which can measure this range of temperature. Now we have also J-type, which iron and constantan. It has this sensitivity and can measure this range, and so on. So when I say type of thermocouple, it depends on the material used. So which going to result in special characteristics. So we are going to use material which will cause type. The result of having this type of material is certain characteristics. Type of thermocouple, I think, is discussed in the previous slide, and we know that from type to type we are going to find different range, different sensitivity, and so on. So these are the type, the rest of the type: J-type, N-type. The type of the thermocouple for easy use is identified by some countries' standard, like in, for example, Denmark. They are going to have certain standard. In USA, it's having certain standard. In UK, there is a standard. In general, in Europe, there is a standard. What I mean by this standard, they are making it easy for the one who's using it. Like, for example, K-type here, K-type, is going to be green from outside, and one of the wires green and the other is white under this standard. And under this standard, the British standard, you are going to find that K-type is red from outside and brown with the blue from inside. It's not to be memorized here. It's just to tell you what is the meaning of this color. This color is having a meaning. So once you are dealing with certain standard, if you are familiar with that standard, once you see the thermocouple, you will know its type, and you can figure out its characteristics somehow. Thermocouple table is making relation between temperature and voltage. Of course, we found that there is equation. We mentioned earlier equation getting this relation, but for easy use, the company creating or making a tables, those tables are making it easy to find the relation between the temperature and voltage for easy use. The table, I'm putting sample of it. All the tables or some of the tables are shown after a while, but the table is showing us a temperature, then the type, each type. So under each type, you are going to find the voltage proportional to that temperature. Like, for example, I will take the temperature of 240 negative. 240 negative, in E-type, you will find the voltage equal to minus 9.604. In J-type, it's not covered. I mean, J-type cannot measure this value. In K-type, you will find the voltage is minus 6, 3, 4, and so on. That's how you can measure the quantity. Let us see what you want to tell us in this example. He said, for example, type K thermocouple at 200 degrees Celsius with zero reference. Remember the reference which we said we will put it in ice bath. It's 0. You will find the voltage is, that's how, V of 200 degrees Celsius for K type. So you will go to K type. As I told you, it's in the table after a while. Under K type, you will look for 200 degrees Celsius here. 200, not minus 200, 200. Go down. You will find that the voltage at K type, you will go, when you reach to 200, you will go to this type until you come with K type. Let's say this is the value, and you will take it. I am putting this as an example. You will see this in the slide after a while, where I am showing the full table, where you can see the 200 degrees Celsius. How about the other way around? If I have the voltage and I want to check the temperature, it's the same thing. We are going to check, we have to know the type we are using. So like here, he's saying we are having K type. If K type, this is K type. So he said that the voltage is this much. So we are going to go until we find the voltage. Then we will check to find the temperature. So now if the value we are looking for cannot be found as it is in the table, what I mean, I am putting example here. Let us say I am dealing with E-type. In E-type, I found that the value is, for example, 15.9. The voltage is 15.9 millivolt. 15.9 is going to be somewhere here. So it's in between. So if I want to measure the temperature, it's not 230, the value of the temperature, not 230 and not 240, it's somewhere in between. For that, we are going to use this equation to decide on the exact value. How to use the equation? We are going to use, I said just now, the value will be located here. So if it's located here, that means the temperatures will be between this value and this value. So this value is considered T low, this value considered T high, this value we consider V low, this value is V high, this is V high, and V measured is this value, this is V measured. So everything is given. When we substitute all the quantity here, when I get the values from the table and I substitute, I will be able to calculate the temperature. Remember that when you are doing the calculation, if I find that the 15.9 located here, that means my answer will be between 230 and 240, no other way. You are going to find your answer between 230 to 240. If your answer not within this range, means there is something wrong in your calculation. So example here for the calculation, the example is saying output measures from Cromel Constantin. Thermocouple is 14.909 millivolt. This is the voltage measured with a reference junction of 0. That's fine. What he want here, we want the temperature. So Cromel Constantin is E-type. Usually these things, you don't need to memorize it. It's going to be provided. If the question comes this way, the table will be provided. So it's E-type thermocouple. Now, if I will go to search for it on the table, you are going to find that the temperature is 220. No need to check this example because it's very simple. How about this example? If I want to check this example is, let's follow it. Read it. The voltage is 6.6 millivolt. Measured type is J type. So we are having J type, remember J type, and the voltage is 6.22 millivolt. 6.22 millivolt is going to be somewhere here. In J type, 6.22 will be somewhere here. Which means it's going to be You take these datas between 110 and 120, and the voltage will be these two voltages. So you are going to take the data as I mentioned earlier. T low is 110, T low 110, T high 120, T low 110, V high is 6.359, V low is the low voltage, which is this value, multiplied into Vm, which is the measured quantity. Measured quantity is, as he said, 6.22 millivolt, minus V low, which is the lower voltage. When you calculate it, the result is 117.4, which logic, it's coming between 110 and 120. That's how we can deal with this kind of example. I mean, when we are measuring the voltage and we found it's not directly available in the table, we can apply this equation to calculate the exact temperature. These are the table I talk about. I am putting them here for you just to have a look at them. This is the rest of, this is also the rest of the table for the thermocouple. That's it for the thermocouple sensor. In the next class, we are going to deal with more sensors. Thank you very much.